Do you know how to switch the limits of integration in a double integral? It's a skill that is so useful that in some cases, like this one, it's essential to being able to solve this integral entirely. Switching the limits of integration in this case is essential because in this integral, if you were going to integrate it with respect to the bounds as they are given, then you would have to first find an antiderivative of sine of y squared with respect to y. And this function, sine of y squared, is one of those functions that have no elementary antiderivative. So that's what's called a non-elementary integral, and we would have to use numerical methods to solve the integral as given. But instead, we can switch the limits of integration. The region we're integrating on is given by x between 0 and the square root of pi, and y between the line y equals x and y equals the square root of pi. Instead, we can think of this region as y going from 0 to the square root of pi, and x going between x equals 0 and x equals y. Now I have changed the limits of integration so that the outer limit denotes that y is going between 0 and the square root of pi, and the inner limits of integration denote that x goes between x equals 0 and x equals y. Again, note that the limits of integration here have changed, and also the order of dx and dy have also changed. Now we can start the integration itself. The integral of sine of y squared with respect to x is the integral of a constant function, so that is just x times the constant evaluated at the limits of integration, so between x equals 0 and x equals y. Evaluating this at y, I get y times sine of y squared. And now we do the integral with respect to y of y times sine of y squared, which is now an integral that we can do because that is just the derivative of minus a half times the cosine of y squared. If we evaluate at the limit of integration between 0 and the square root of pi, I get minus a half cosine of pi, because the square root of pi squared, plus 1/2 of cosine of 0, and cosine of pi is minus 1, cosine of 0 is 1, so the final answer is 1.